All right, so we're going to talk about how to tune a multi-terabyte database, but a little bit about me. Like Sam said, I'm a principal data consultant. There's my contact information and my LinkedIn. I am an Octopus insider and a Redgate community ambassador, which that means I do a lot of DevOps as well as database tuning. I run the Jacksonville SQL Server Users Group, and I also an organizer for Jacksonville SQL Saturday here for the last few years. The avatar there is my alter ego. That was at Past Summit last year. They had a booth where they had AI creation of you as a superhero. So I really like that image. So it's a lot of fun. All right, so let's dive in. How to tune a multi-terabyte database. So a couple questions first. How many here are DBAs? How many of you are DBAs? If you could throw up your hand or put DBA in the chat window. I'd love to see how many are DBAs here currently. Nice, a lot of DBAs. All right, how many of you are not DBAs? Do we have anyone in the crowd who's not a DBA? Okay, I see a developer, data model, DBA. Looks like he's wearing every hat possible there. SQL developer, okay. Good. Data engineer, some more devs. All right, good. All right, so here's my next question. What versions of SQL Server are you using in production? Let's go with the oldest and latest version of SQL Server in production. I just want to get a broad sense of how to cater the session on, because there's some things I can cover that are more old for older databases or newer databases. Oh no, someone says 2005. There's the exit. That's that little button right there. 2008. Oof. So, all right. There's a few old ones still hanging on. Okay, I see a couple Azures now. Good, good. All right, so it looks like we have a pretty broad mix. I'm glad no one said 2000. If someone said 2000, well, I might have to eject them from the meeting. All right, so now we know kind of what versions we're using. What additions are we using in production? So standard or enterprise? Okay, so a good mix. Some are using both. Yes, you are lucky if you have enterprise in production for sure. Okay, good, good. All right, so another cool question. What is the largest table in your database? How many terabytes is your largest table? Whoa, Express. You're using Express edition? What are you guys using Express for? Do you have like mobile devices that you're using that for? Or Saul, can you come off mute and tell us, or just throw that in the chat there too? All right, so
We might have
far
to
we've
might have to give him permissions if he wants
oh okay.
to speak.
I'm gonna say if you want to undo everybody's permission, allow them to talk, just can you do that or no?
I know I can do it per person. So hold on. You said
Okay.
Saul? Yeah.
Saul, I believe. Yeah, he said
All
he's using
right.
Express Edition.
I have given him permission to speak. So we'll see if he pops on.
Okay. All right. So I'm just
Can you hear me, guys?
yeah, I can
Yes.
hear you. So what are you using Express for?
There's some satellite applications that they use for some production systems, and some of the managers decided to stay, let's say, disconnected from all the other versions because of some sort of development arrangement with the consultant company. That's why.
Interesting. Okay. And Jeff Moden said he's using Express for import file from staging. So is that like on a personal instance, like personal use to import in? just as a stepping stone, it sounds like. All right, so the biggest one I'm seeing here, database size looks like, what is it? 9 terabytes, maybe 10 terabyte. Yeah, 9 terabytes for one table. That's pretty decent size.
For
All right,
for
so
a table, not the
for
whole thing.
well, yeah, I asked the table. Now I'm asking for the whole thing. So
Oh God.
what is the largest database you have right now in production that you're supporting terabyte wise?
Sorry, I'm a retired DBA, so 10 years ago, 1 terabyte was the VLDB marker. So obviously that's
Yeah.
changed.
So I think the largest I've encountered in giving this session, one individual had 50 petabytes.
Ugh,
Was his largest database, which is just phenomenal. It was huge.
oof.
Oh no, look at this. Someone sent an unnamed vendor, gotta love those vendors, has an app deployment that auto installs Express on the app server. Oh, that's painful. That's very painful.
It's saving on money on
Said the
licensing.
head words. Yeah, yeah. And on actual usability. All right. So it looks like the largest database coming through, or yeah, overall is 13 terabytes, 24 terabytes now. Okay, good. So a couple big ones there. So it looks like most of the database sizes are from, yeah, I mean, they're, I said mid to, 5-ish to about 5 to 15. Looks like it might be the average scope there. Okay. All right, cool. All right. So I don't know about you, but I'm sure some of you who have those large databases have encountered some problems. So here are some of the problems that some of my clients have encountered with their large databases, right? So queries take minutes to run. Processes sometimes take hours to finish. In some instances, they had to increase their application timeouts in order for them to return results from the database because it was taking so long. Some databases have indexes that were so large that maintenance couldn't be completed each night, right? They couldn't do it. They had to split it up or not do it at all. One client I had tried to create one index. It took 4 hours and 8 hours to create an index on a table with 1 billion records. Backups, 12 plus hours. I mean, that's eating up a lot of time for backups, right? Some of the databases were kept in simple mode due to transaction log backups being unable to keep up, right? Their disk subsystem couldn't keep up, their SAN couldn't keep up. And then another issue I've encountered is that sometimes you're using nested virtual hard drives for data in VM hosts, and that can be a performance bottleneck. And then another one of my most encountered ones is that the entire database is in a single file group, the primary file group. All right, so first things first, hire a DBA if you don't have one, preferably one who knows servers and storage, their SAN infrastructure. Actually, there's one other question I need to ask. Oh, I guess we did have some say Azure, but everyone with the large databases, are you primarily on-prem with your databases, or are you in the cloud with the large databases? I saw a few say Azure. Okay, so it looks like so far majority is on-prem, some are in the cloud. Okay. All right. Another option is to move to Enterprise Edition because some of the issues that you have in performance can be automatically solved with just moving to Enterprise Edition, right? And a lot of your maintenance tasks, so your index maintenance, go from single to multi-thread, which is a huge improvement from standard to Enterprise Edition. So just maintaining your database is a lot easier. Obviously, it's a lot more costly, but there are ways to also improve that without having that huge cost effect be too detrimental to your configuration. All right, so what we're going to do in today's session is we're going to talk about how to review your configuration, test your network, your server, and your SAN performance. This will apply to IaaS in the cloud as well as on-prem. If you're in Azure SQL, some of the testing you won't be able to do, but the design and architecture things will still apply. So the next thing we need to do is kind of determine what kind of data you have, whether you're doing this in a OLTP system or whether you're doing a data warehouse. Determine your criteria and filters that you use predominantly for your queries. We'll talk about how to review and adjust your data types and sizes to maximize your performance. We'll talk about actually how to move and fix that data in SQL Server. And then we'll talk about how to release that unused space, in the primary file group and primary file where the data is, existing now, to release that back to the SAN. All right. So if you had to take a trip, cross country, would you rather ride a bicycle or would you rather ride a motorcycle? Some may vote for either, but I think I'm going to get there faster on a motorcycle than a bicycle. If I had to take a farm full of hay and take it to market, would I want to use a pickup truck or would I want to use a tractor trailer and take it in one trip? If I had to fill a swimming pool with a garden hose, if I had to fill a swimming pool, would I use a garden hose or would I like to use a spillway? I think a spillway would work a lot faster, right? Or how about 4 spillways? So this is what we're going to talk about and how to improve your database design. So first, we need that better design. We need to step back and think about how we're setting up this database. Now, a few of you said you're accidental DBAs, so you're coming onto the scene after the fact, right? So you can't necessarily design it perfect from scratch, right? So what I'm going to show you here is simple ways that you can improve your current system with a better design. All right, so to review we're going to review the current system and test it. We're going to review and adjust the infrastructure, okay? And then we're going to review the different data types that make a big difference. And then we're going to talk about how to create the logical and physical separation of the data. All right, so how do we measure throughput? How do we see what's going on in our system right now? So I like to use a couple tools. One is I look at a query that gives me the latency of my current disks. So here's a query. You can copy this and I can make these slides available so you can grab this. But what it'll do is it'll actually give you the current IO in gigabytes in and out of the system for every database. And then it'll tell you what percentage, obviously, of throughput that you are using in your database system. So you can see in this instance, tempdb is the number 2, and this database is number 1, right? So 120,000 gigabytes since the server has been up is going through the server of data. So if we want to look at the latency per database file, here's a query I like to use. And this will show you the latency for every single database file in your SQL Server. So as you can see here, the write latency is fairly high for this, over 1,429 milliseconds latency for these guys. This is extremely high. Your latency for your data files, read and write, should be 20 milliseconds or less. For tempdb, it should be 10 milliseconds or less. So you can see here, we have a lot of performance issues with these disks under the covers. So a quick check of your disk subsystem, you can use a tool called Crystal Disk Mark. You can run this on every drive that you have in your production system or whatever system you're testing and see what your throughput is. So you can see here in this client system that was running at 326 megabytes of read and 250 megabytes of write. That's pretty slow. Next, I was like, hey, let me test my laptop and see how fast my laptop is. Well, check this out. I've got over 3,000 megabits per second of read and 1,972 megabytes for write. So that's pretty fast. Needless to say, my laptop is quite a bit faster than this production system, which is kind of sad, right? My laptop really shouldn't be that fast. So just to give you a quick peek in the future, here is what the server looked like after we upgraded. We ran the test and we went from that 300 to 2,700 and from that 250 to 1,500. So you can see a big difference in performance with everything that we'll be talking about in this session. All right, so another way to more deeply test is to run something called disk speed. It used to be SQL IO, And you could specify your reads, your writes, your byte size, how big of a file, what drive you tested on, and it gives you the output of the drives, right? An output of the test. So it gives you IOs, it gives you megabytes, it gives you IO per second, and then your average latency. So here in this test, you can see it took 183 milliseconds of latency. So you can do, so after we did our improvements, you can see here that our IOPS went through the roof. Our megabytes per second also went quite high, 4 or 5 times higher than it was. IOPS increased tremendously, and then our latency went down to 10 milliseconds. So substantial increase before and after these changes. So here's another example of another drive. I believe these were the log drives, and these were, again, high latency, but then we were able to improve them tremendously and get that latency down. So overall, you could see we did a random read test, random write test, read sequential test, write sequential. So these are each individual tests that we did. Not really a true, mix of like 70-30, which you could do. But you can see the before and after of each one of those here. So megabytes latency for each one of these, and you can see how vastly improved it went. There's a question: what is the overhead of running these diagnostics, disk speed and crystal disk mark? There is overhead. I've run them on production on live systems that have performance issues. It's not going to tank the system unless the system is extremely busy. You can run these at night or at a low performing time in production if you're worried about that. But I haven't had any issues where running these is going to cause any outage or any degradation to the system. But this also kind of gives you more of a load test of when the system is busy, how is it going to affect it. So you could run it during a busy time, right, for 5 minutes, and then you could also run it in a non-busy time as well to get the picture difference between it. And I have done both of those, but there have been no adverse effects to running crystal disk mark in the middle of the day. If you're going to run a prolonged test with disk speed, however, you could potentially run into a situation there. But again, I keep my tests relatively small. The one thing you want to make sure you do when you do either crystal disk mark or disk speed is that you go beyond your SAN caching size so that it actually reads and writes to the disk. So if you have, a 4 gig cache, you need to write at least 5 gigs, have a 5 gig test file to go so that you go past that and actually are reading and writing to the disk subsystem. All right, so another question: how many of you, and you can, if you know the answer. If not, you don't have to type in. But do you have multipath set up from your SAN to your host or your physical SAN? For those of you on-prem, so do you know if you have multipath set up? What is multipath? Multipath is multiple network cards in your network that go between your host and your switch usually, and then your SAN appliance. So if you don't have multipath, that's something you definitely need to contact your SAN administrator and your infrastructure admin and find out. And then if not, you definitely need to get that set up. So the next question is, what is your connection speed from your server host to your SAN? If you know, go ahead and put it in there. Is it 1 gig? Is it 8 gig? Is it 10 gig? Is it 25? Is it 40? Is it 100? Every connection you have between your host, your server, and your SAN means you have more bandwidth. So the one client I was showing you an example of that I helped, they had a 1 gig connection between their host and their SAN. And let me tell you, it's not going to go very fast when you have 15, 20 or more SQL servers between your VM and your SAN. If you only have 1 gig, you're going to experience a lot of latency.
Jeff, we have a second question regarding temp DB storage.
Okay, what's the premise? Shared space on disk pool with a lot of drives or dedicated pool, which is 2 drives, RAID 1. So the best storage for tempdb is if you're running in 2019 or newer, maybe run it in memory, right? That's going to be your fastest. If you have to run it on disk because of maybe size or memory limitations, the fastest is either, obviously on NVMe, or if you have to use spinning disk or SSD, go RAID 10. RAID 10 is going to be the fastest as far as performance there for that, and you're going to get your lowest latency. And I would definitely keep that separate. I would keep your tempdb separate from your other databases. All right, I see a couple here put in the 10 gigs or more, so that's good. Another thing I would ask your SAN and network administrator is, are jumbo frames enabled? If you don't know what jumbo frames are essentially a larger packet size that is transferred across the network. So think of a train. If you have a train that only has 5 boxes on it, but then you have a train with, a train with 5 boxes. Then you have a train with 2 containers on it. That's the difference between a regular packet size, which is 1,500 bytes, versus a jumbo frame, which is 8192. So if you can ping your SAN from your server and ping it with -L and do 8192, and it times out, that means the jumbo frames are not enabled. Someone said that they had issues with it and disabled it. So I've seen that. One of the things you have to consider if you're going to set up jumbo frames is make sure if you have issues, because sometimes you can, have it only enabled for your storage network. So have it enabled only between your host or your server through your switch and to your SAN, only in that network. Because sometimes you may have other servers and other appliances that may not be able to support that, but your SAN should. And as long as you're direct link between those, hopefully you shouldn't have an issue. So if you ping it under 1,500 bytes and you get a reply, well, then you only have standard packet size enabled. Again, how much throughput, how much you want to put through your pipe. If you have jumbo frames enabled, you're going to be able to transfer more across your network in a shorter frame of time. All right, so work with the infrastructure team. Go out, buy them lunch. Go meet them after work and say, hey, this is what we're trying to do here, and bring them to your side and show them some of the things you're struggling with and see if you can get some more performance out of your system. Validate how many NICs or network cards are on your server, your host, that are connected to your SAN. Validate the bandwidth of those connections. Validate that the switch is able to support the bandwidth, because you could have a fast SAN, a fast server, but your switch is your bottleneck, right? Your switch has to be able to handle all the throughput you're pushing through it. Validate that there are multiple connections from your switch to your SAN, because again, you could go from 4 to 2 to 4 and you still have a bandwidth problem there. Validate that the latency on the SAN is internally showing 5 milliseconds or less, right? And then once you get the SQL server, make sure that it's 20 milliseconds or less. Validate on your server that all NICs are connected and are active on the SAN. Sometimes you could have NICs there, but they're not actually in use. So make sure that they're in use. And also a good practice is validate and make sure that all the data is on its own network. Don't share the network with everybody else in the company, because as soon as they open up that next cat video and share it with the team, the bandwidth is going to go to crap, right? Validate that jumbo frames are enabled on that network, on that data network, to ensure that you have maximum performance. And then validate that at all levels there are redundancies, right? Because you don't want to fail over right in the middle of the day when you have a performance issue or a hardware failure and go back to being crawling across the country, because that's not going to work. All right, for the drive configuration, now this applies for IaaS and on-prem. Make sure that your data and log drives are formatted in 64K blocks. You can use the sutil fsinfo, ntfsinfo command at the DOS prompt to C. You just run this per drive. And then you can see here that in this particular case, this drive is only 4096. So that's 4K. What you want to see is the bytes per cluster to be 65,000 here. And that is telling you that it is indeed formatted at 64K blocks. So I think we did have one 2008 and 2005. So for those two people in the call that have that, this is for you. Make sure that your disk offset in Windows for those servers, if you're running Windows Server 2008 and older, is set correctly. If it's not set correctly, you will lose 20 to 30% of performance. So be sure to fix this particular item. And just a quick summary on this, because there's only a couple of you that are using this. The offset is essentially the start of your SAN disk or your data disk all at the same point of the disk. Here's a couple links you can click in and find out a little bit about how to do that and how to align those. But making sure they all start at, say, the 1 megabyte block on the disk will increase your performance.
Jeff, we have a follow-up question regarding the memory in TempDB.
Sure. Let's see. Yes, to answer his question, he said by in-memory TempDB means memory optimized TempDB metadata option or something else. Yes, so the metadata option, turn that on for TempDB. So as long as your usage of TempDB, and you should monitor your usage of TempDB, as long as you're monitoring your usage and it's within a known parameter. So let's say over a given, month, that you don't ever reach more than, say, 5 gigs or whatever the number is of TempDB usage at any one time, then yes, you could put TempDB in memory, make sure you essentially allot for yourself that you can support that 5 gigs or whatever that number is in the memory on your server, right? And then you should be able to support TempDB in memory. Now, if you're using, hundreds of gigabytes of TempDB, that may not be feasible because you may not have that memory. So you have to consider that and monitor your TempDB first before making that decision. But yes, for the best performance, so you don't actually have to write the data to disk, use TempDB metadata, and that'll keep that all in memory. All right, so for older operating systems, make sure that you have the disk alignment in place. And this is what it looks like. All of these disks are my SAN disks here, and you can see they all have the same starting offset. So that's what we're looking for. So this is a command you can run in DOS to make sure that you have the right size. All right, are you using NVMe, SSD, or spinning Rust? How many of you know what your SAN is? And if you do, go ahead, throw it in the chat. I'd like to see what is everybody using there for those on-prem servers. Nice. I see a lot of NVMEs. That's good. That hopefully means that you have very low latency. Pure storage, good. Nutanix. How do you like Nutanix? I've had some experience with that. Some has been okay. Some of it has been a little slow. Nimble. Yeah, I love Nimble. Nimble and Pure are my top two. Kevin, hit me up after if you want to. We can chat about that. All right, so next question. Is your SAN managing your disk configuration, right? So are you cutting out the drives specifically for your LUNs, or is the SAN doing that? So like if you have a Nimble or a Pure Storage, it's managing all that for you, which is great. Are you using RAID? So if you have a SAN administrator, are you using RAID? What is your RAID configuration under the covers? Is your RAID the same for your data drives as your log drives? That's something that I would ask. So RAID 0, striping, not fault tolerant. RAID 1, mirroring, no hot swap. RAID 5 is probably the best for data as far as performance goes. And this applies to both spinning disk and SSDs if you're managing this yourself. RAID 6, I'd recommend staying away from this if possible. It's a little more redundant, but it's definitely slower than RAID 5. RAID 10, very fast, has mirroring and striping. Rebuilds faster, but obviously because it's double the disks, it's more expensive, right? So using this for, say, a RAID 10 for your temp DB or for your log drives is definitely a better option than using for your data. So I like to use RAID 5 for my data, RAID 10 for my logs and temp DB if I'm carving up the system. Now I know I believe Pure and Nimble, they kind of manage the SAN in a similar fashion where they have two different types for the disks. So as long as you're SAN administrator, and as long as you configure the SAN to be the correct type for your drive, so a SQL data drive or a SQL log drive, the SAN for Nimble and Pure will perform very well. What about Azure? So they just came out with a brand new series of servers that are extremely fast, have a very large throughput ratio, and these are new, and these are similar to what an on-prem server would be that would hold, multi-terabyte databases. There hasn't been a lot of this in the IaaS picture in Azure. And as I'm sure a lot of you know, it costs a tremendous amount to have fast disk in Azure. So here's the new MBSV3 series VMs. And you can see here that they have quite a bit of megabytes of throughput for these. Very high CPU and a lot of memory here as well. And these VMs can support 64 disks across all of them. So just recently they have added these. I've been trying to look for pricing, but haven't come across it yet. I don't know if they're still working on that, but they finally have some pretty fast servers out there.
Jeff, we have a question from Paul regarding the RAID 5 for data. He's
Sure.
asking, what about that write penalty overhead? Why not RAID 10?
If you have the money, go for RAID 10. If you can have the disks, obviously, because that'll be your fastest. But if you're trying to save a little money, again, because of the way SQL Server does indexing, as long as you have a decent enough of memory for majority of what you're touching, RAID 5 is sufficiently will sufficiently perform well enough for you that you don't have to have it in a RAID 10. So if you have the money, go for RAID 10, right? It's double the disks. But if not, for the data, RAID 5 will work. Just make sure you have enough memory for your operational needs. Here's another set of that new series. This is the MBD SV3 series. And again, you can see the max network bandwidth throughput in megabytes goes from 8,000 to 40,000. I think most of premium disks start around 200 megabytes throughput, and then they go up from there. But some of the, the standard VMs or the memory optimized VMs right now in Azure, they don't support a tremendous amount of throughput. So for larger database systems that have many terabytes, it's not really feasible to put that on Azure because it can't sustain the throughput, right? But now we can with this new series that have come out. So that's kind of cool.
Another question regarding RAID. Arthur is asking, would you consider local RAID 0 for temp DB?
I would probably do a RAID 1 just to make sure it's redundant so it doesn't So you could stay live while the server's there. I don't know if I would do a RAID 0 for TempDB. I mean, you could, but I would probably do at least a mirroring for that if that was a hard option for that.
All right, thank you.
So for knowing your data, right? So we need to understand what your data is doing to kind of help how we should design some of this here, right? So are you inserting, updating, deleting CRUD, OLTP system? Is that your primary use? Are you doing logging only for your large tables and databases? Do you have a data warehouse? Is this what's housing your data, right? And then next thing, does it make sense to partition? Or does it make sense to archive? Like, do you need to archive some of the data, remove it, or offsite it, or move it to cold storage? Or should you just partition and try to only touch the latest data? So how would you filter and query your data? Do you do it mainly on date? Do you do it on a flag, active or fulfilled? Do you do it on an identifier, right? Do you see a status when you do your queries all the time? If you're partitioning, what column makes sense? Think about it. Primary key ID, date, time. If you're going to do a partition by date, you need to make sure, obviously, every query uses the date time. Are you using your clustered keys in your queries? And are your indexes supporting your queries? Right? You got to make sure that that's the case across the board. Do you really need 2.5 billion records in that table? Probably not. So determine your retention periods. Talk with your legal team, talk with your data team, figure out, do you really need that data on your live production system, or can they be archived off, or can it be deleted? Does all of your data need to be on hot storage? Can you get away with keeping, just the latest few months of data on your SSD or NVMEs, and then to put the rest on, SSDs or spinning disk? Determine your typical search range. Do you search within the current month, the quarter, the year, the last 2 years? Based on the number of records in the period may also determine your partitioning structure. So consider that. All right, how many of you know and are using a Unicode data type in your database right now? So those Unicode data types are for SQL Server nchar, and then varchar, and then text. And that stands for national language. So my question is to you, do you really need Unicode characters? If you have any of these languages in your database, then yes, you need Unicode characters. But if you're not, then you actually don't need them. So if you're using text and image in your database, so some of you who are in 2005, 2008 may still have some of these. I hope nobody in Azure has them. But guess what? They're deprecated, so don't use them. You can move them to the new varchar max and var binary max columns. And just changing the data type will not help performance or space savings. So just keep that in mind. If you upgrade, it won't help. Is there a difference? There's a huge difference. nvarchar uses 2 bytes or more per character. Varchar uses 1 byte. So if you don't need it, don't use it. You're doubling your data size. So just to give you a quick example of the data size, one text could be 34 characters, 34 bytes for the same string versus 17 bytes for the same string. Test that over 600 million records, and guess what? It's 18 gigs for that nvarchar field versus 9 gigs for that varchar field. Huge difference. If you fill the whole text string, well, it'll be 8,000 characters in this case, 8,000 bytes for 4,000 characters, or 4,000 bytes for 4,000 characters. Do this again for 600 million records, and you're talking 4 terabytes if you use nvarchar versus 2 terabytes for varchar. So just by changing one column data type, you could save a tremendous amount of space in your database. Big int, small int, tiny int. What should we use? Well, guess what? Big int uses 8 bytes. Sure, it gives you a whole lot. Int gives you, or only uses 4 bytes. So half of that it gives you 2.1 billion. Small int is 2 bytes. So if you don't need a large number, then obviously don't use int or big int. And then tiny int. What I found is that you sometimes run out of int, right? So one of the things that I've been able to do is double that by using negative max int. So if you need more than int or small int, consider going negative max int. Now you doubled the amount of integers that you can have as a primary key in a table. So you have 4.2 billion available to you. And then negative max small int will give you 65,000. The size difference, again, each one of those different data types, you can go from 4 gigs or 4 gigs for your big int or 2 gigs. So it cuts it in half for that. So definitely try to stick with integer as your primary key and not use big int if you can. Date time and date time 2. Date time 2 came out, I think, in 2008, and it allows you to essentially trim the date size, which allows you to give you even more precision, but then you can also have a less size. So date time 2 is a solid 8 bytes, but sorry, date time, the original date time was 8 bytes. Date time 2 could run from 6 to 8 bytes. So you have some variance there, and it's more accurate. So the precision is 7 digits for the full 8 bytes, 6 bytes for precisions less than 3, 7 bytes for 3 and 4, and the rest require 8. So to look at, say, a date time value here, and then a date time 2, it's exactly the same value, but it's 1 byte different. I know it's not a lot, but when you have 1 to 2 date fields per table across your entire database, it adds up. And if you don't need that precision, then obviously you could drop it down to an hour, minute, seconds, and you could save 2 bytes per row, per column, per table. So in a table of 2.5 billion records, you could save about 5 gigs of space by just changing that data type. So here's another example of what that looks like. And again, you're shaving off in this particular instance with 600 million records, about a gig to go from date time to date time 2 with a 3 precision, having the same exact value. So 8 bytes, 6 bytes, and 7 bytes. Date time, 4,500 megabytes. Date time 2 with just seconds is 3,400. And then the final one there is with 7 bytes at 4,000 megabytes. So let's take a table that I had converted for a client. I changed my created date time from 8 to 6 bytes, modified date time 8 to 6 bytes again. Order date, we didn't need timestamps, so we actually went to an even shorter data type by just using date with 3 bytes. And then we did the fulfilled date, the return date. We changed our nvarchar from 8 to 4. And one table with 600 million records went down from 20 gigs to 5 gigs. We had one nvarchar column that went from 4 to 2 terabytes. So overall savings on that one table was over 2 terabytes just by changing data types. So now multiply those savings by however many tables you have with multi-million or multi-billion records, and it adds up. The savings can be seen on your SAN, your disk space, your backup, size and time, your restore times, and bytes transferred in your application. All right, so I want to talk about how we can actually make this happen. So be sure to turn on instant file initialization, because this will help with your file growths and your data transfers. So turn that on. You can add the service account to the user group who's doing this, or you give them the correct permissions when creating the file groups. Why? Because the speed that'll help grow on disk. It doesn't zero right out the files. And if it doesn't, it'll affect performance. So you'll see long wait latches when you have to grow your files. It'll also speed up restoring databases. So keep that in mind. So you can check to see if it's already enabled by running this query. It'll tell you yes or no. You can also go into your local security policy and user rights assignments, perform volume maintenance tasks, and add this. I think now SQL Server 2022 automatically adds this for you when you install it. So that's nice. But any older version, you'll have to manually come and add this. Just add the service account of your database server here into that group administrator if you don't have access to do it the other way. All right, so we want to create file groups. I like to create file groups, one for data, I like to call it FG data, one for indexes, FG indexes, and one for my blob data, FG blob. If I'm going to partition, I will name the partition groups, as needed, either year, month, or year, or I'll name it monthly if I'm doing like a rolling file group. Change the default file group for all new objects to FG data, because if you don't, guess what? The next time you do deployment, potentially you'll deploy to primary and then you'll have to empty it again. It could get bloated. So make sure that you change that default. You do that in using this script here by changing the default after you add the file groups, or you can go into your properties and tick this box here on the right. Now you want to create at least one file per file group. I like to place them on separate drives. Most of the time I end up creating multiple files for each file group and striping them across drives. It allows for better performance. So here is an example of creating, a file for the FG blob file group and FG data and FG indexes. And then here is an example of how you can do it through the UI if you don't want to use it in the script. So if you have a data file that is large, you can see what size your data is and then make your data file that size, pre-grow it. Same thing with your indexes. As you grow this before you move the data. If you're doing partitioning, you can add all the months and years of partitioning here. Obviously, be sure to keep your empty group so that you can add more. I like to pre-grow these out a little ways. I only add the files for this though at a 1 megabyte interval, so I'm not taking up a lot of space, but I'm ready to go, and then I can switch them out, later on, and I'm not caught at the last minute with having to add a file. You can also add this through the UI. The same fashion here, just creating the file and assigning it to the correct file group. And then for the date partitioning, I have a partition function here and a partition scheme, which we match the date with the partition scheme, which is the file group in this case. And here's a script to how they do it here. Now for partitioning a table, if you're going to partition it, make sure that when you create the table, that you create it using the scheme with the date field that you're partitioning it on, or ID if you're partitioning on that, and then specify that for your primary key as well. Be sure to also add data compression. I like to add data compression at the page level for this because it helps increase performance or decrease the storage and increase performance here. Also, if you're going to have a non-clustered index, make sure your non-clustered indexes for partitioning are also stored on that PS monthly date time, so that when you drop or move that partition, the indexes move with it and it doesn't stop you from moving data.
Jeff, we have a question from Garrett.
Sure.
Asking, what do you think about using IFI for the log file in 2022?
I would use IFI for everything in SQL Server, so data and log files. So I would turn it on based on the service account. Usually you have a service account that's running SQL Server. You should assign that service account those permissions. And then that service account, whenever it does any sort of disk growth, whether it be for log file or data file, will automatically instantly initialize that, right? So as long as a service has that access, it does it for both. All right, let's say you need more performance. So if greater performance is needed, then create multiple files in each one of those file groups, data, blob, indexes. Place them each on multiple drives, right? So that you could spread out your IO load across. So let's say you have a slower SAN, or maybe you have a fast SAN. You need more throughput. You can do the same activity to work. So in this case, we added 1, 2, 3, 4 files to blob, 4 files to data, 4 files to indexes, right? And then we place those on different drives, D, E, F, G. I like to label them. So if you start with 1, you can obviously add other numbers. You can go beyond this, but I try to stay, I start usually with 4 for each type, which gives you a total of 12 for the entire database. So you can do that with script, or you could do that here inside of the UI. Again, the same thing. You create the name, you assign it the correct file group, and you rotate the drives with the correct number of files. Pre-grow those files. So if you go from 1 large file to 4, pre-grow them, right? So split that 1 into 4. So once you do that, now your files are lopsided, right? You have some data in indexes and nothing here. You've pre-grown that. So what you need to do is ensure that all the file groups have the same auto growth setting, and then distribute the data evenly in the file groups. So you can do that easily. So you can enable trace flag T117 for your server, and you should do that at startup. If you have 2014 and older, if you have 2016 and newer, you have to enable auto grow files flag in the database. So here's how you would enable T1117 on those older instances of SQL Server. You just add it into your SQL Configuration Manager, your SQL Server, your startup parameters T117, add it. It then shows up right here. Then you have to restart your server. And then if you have newer, you have to come in here into the file groups and tick each one of these flags here on the right, auto grow all files. The only problem is when you do this, you have to be in single user mode. So Microsoft has changed the way they do this, and I really don't like this, where you have to put the server in single user mode. So if you ran this command, you get a failure because somebody's in the database. So what you have to do is you have to find everybody on the server, kick them off, and then you can put the database in single user mode, auto grow all files, and then put it back into multi mode. So just keep that in mind. You'll have to do that during the maintenance window in order to turn that on. And then you'll get this nice message, auto grow all files has been set. All right, how many of you have heap tables? If you have heap tables, hopefully you don't, but you may, create a clustered index on the heap table. Ensure it's created on the new correct FG data file group with compression if possible. Virtual log files. Check your database for your virtual log files before performing any table migrations to new file groups. Make sure your log file growth is set to a specific size and not a percentage. Make sure your growth size is large enough not to create too many VLFs. The sweet spot for this is Microsoft recommended best practice is about 8 gigs, so 8192. That creates the minimum amount of VLFs for every auto growth. You may have to shrink down your log files first and then grow it that once again in order to get that performance. So this will increase the performance of the transactions, the backups, and the restores. So Pedro has a nice script I like to use that tells you how many VLFs that you actually have. This one client I went and helped had over 7,000 VLFs because they had a small incremental growth for their database, and it kept growing and growing and growing. So you definitely want to clean this up and get this down to, a more manageable size. So in this case, Pedro's script says it probably should have only had 48 VLFs. So definitely a huge difference there. All right, so in order to move blob data types, unfortunately, you can't just move them. You have to create a new table and relocate the blob storage. So create a new table, copy the data to the new table, create table record counts, obviously make sure that everything matches, then go back and drop the old table and rename the new table, and then create your indexes. So if you look right here, when you specify a new table, you can specify obviously the file group that that's on, but in order to manage the blob data, you have to say create or do text image on FG blob, but that can only be done during creation of the table. So unfortunately for those tables that are using blob storage, you'll have to recreate that table. And then when you add your indexes, make sure you use FG indexes, use page compression. And then I always like to sort in tempdb. The reason why I like to sort in tempdb for these indexes is because I don't want to bloat my files. So I don't want to bloat my FG index files. So I sort it in tempdb and then put it into my file group. All right, so moving data. If you have millions of billions of records, batching records may be more appropriate. If you can schedule on a maintenance window, perhaps use simple mode for faster performance as well. Always batch by your cluster key for best performance. So count your objects each file group. When you run this query, it tells you how many objects are in your primary. And as you move them into your FG data and indexes, you can see that change and you know how many you have left. So find all objects in each file group, and then you can move them one at a time. That query right there will give you a list, and you can see what type of index it is, where it's located. An easy way to move clustered indexes without rebuilding the table, if you're not using blob storage, is to use this command: create a unique clustered index, and then you sort in tempdb. You assign it to the proper file group, and you drop existing on. So essentially what that does is it drops the existing primary key by creating a unique clustered index that allows you to move that under the covers without actually having to rebuild the table, which is really nice. Make sure you go ahead and sort it in tempdb as well. And obviously put it on FG data. Compression. Use page compression for tables and indexes. If you have a data warehouse or archive tables, think about using column store compression. A tremendous amount of space can be saved. So here, 30 million records was over 2,000 megabytes. When you did a column store, it was 1,000, 63.1% space savings. If you did archive compression, it took that 2,000 down to 280 megs. 89% space savings. All right, so there's a query that you can run to estimate your space savings. It's included now for column store and column store archive. You can see what it is and what it will be. Now it'll actually include indexes in the last two versions of SQL Server. So when rebuilding, again, use data compression, FG data. Don't forget to go FG blob. For the indexes, use data compression and FG indexes. And then for archive and log tables and data warehouses, use the data compression column store and place that in the FG file group. Minimize your bloat by doing sort and tempdb. And please don't use fill factor. It will definitely bloat your indexes. So here's an example script for you.
All right. I
And
think
then
we're
here's another
coming
one.
down to the wire here.
Yeah. So I can include these scripts, but I show you here how to go from 1 to 4 files, how to move it, and then how to empty the space back to your file group. And there's the resources if you want to look at where I got all this information from on data types. And then there's my contact information if you want slides or want to reach out and have more questions.